My name is Syed Muhammad Ali, and I, along with my partners Ahmed Zaib and Mohammad Sarem Usman, welcome you to our discrete structures final project demo. So today we would be discussing our project, which applies graph theory to analyze inflation in Pakistan from March 2023 to March 2025. We have 3 years of data. So the traditional consumer price index analysis usually looks at price changes in isolation. But in this project, we took a different approach. We modeled 60 consumer items as individual nodes in a network. We then drew the connections between those nodes, between these items, if their monthly price movements aligned across different Pakistani cities. Our main goal with this model is to surface hidden movement patterns in the market, to quantify relationships between the item categories, and to track how this economic network evolves over a 3-year period. Okay, next slide, Ahmed. Okay, let's move on to the data and the methodology that makes this possible. So we utilized the PBS CPI microdata, which gave us a foundation of 32,400 records covering these 60 items across 15 cities over a 3-year period of March 2023 to March 2025. These items fall into 7 standard categories, and from this data we generated 2,700 price change vectors and computed nearly 80,000 cosine similarity scores. Our data pipeline operates in 3 distinct stages. First, we vectorized our data. We mapped the data into 11 dimensional vectors and represented the month-to-month price changes for each item in city and year. And then we calculated the cosine similarity across 1770 unique item pairs within each city to see how closely their price fluctuations matched with each other. And finally, we formed our graph. And in our graph, an edge is created between two items only when 8 or more cities show a cosine similarity exceeding our threshold of 0.7. So now I will be passing it on to Mohammad Sarib.
Next slide, Ahmed. Okay, so that was thank you, Ali. That was all regarding the code and the logic mainly related to this discrete project. Now my job was to mainly show you how the code worked and how to visualize it properly. So it actually showed you something, showed you a visualization of the data, and we had to confirm if actually what we were seeing and what was mathematically calculated actually made sense. So first of all, looking at the central graph, which is the top 10 items by degree centrality, where degree centrality is basically a measure of how the items are connected to each other and in the graph specifically. And in our code we mainly use network X to handle the math, where it checks all the possible connections an item can make along with the connections that an item has made, and then basically divides them and gives an approximate value between 0 and 1, where any value between 0 and 1 gives an approximate connections. 1 means it is connected to every single item, and 0 basically means that it has almost negligent connections. Okay, furthermore, now if we look at the graphs themselves, these are color coded by category, where the bars, where the red is food, the orange is transport, and the green is housing. And as you can see, mostly for the years of 2023 and 2024, the food was mainly highlighting and was mainly taking over everything and was the category that was mostly connected to everything. But in 2025, that was mainly shifted towards housing. And furthermore, now I would like to consider the top right graph, where it talks about the tau threshold sensitivity visualization. Now this was an important part of our project, where we had to show if changing these similarity thresholds had any effect. And in the code, this was mainly controlled by a single parameter, which was the tau variable. Now the in ideal value that, as you can see in the other graphs, we took was zero point 0.7, but in these ones we considered the other two values, which were giving a lot of values. Now the first one, as you can see, which is a dense blob of too many connections, it is the tau value at zero point 0.5, and it basically gives a lot of edges, approximately 1770 to 1775 edges. Almost everything is connected to everything else, which means that everything is tightly coupled and interdependent on each other. This means that any weak price movement in one category would largely affect another category, which was not what we were aiming for. As Ali said, we were not doing this in isolation. And furthermore, if we consider the point 0.9, it is the contradictory side. Everything is not connected to anything. So basically, barely any change occurs. So that was also something that we were trying to avoid. This is exactly why we chose tau equals 0.7 as our default value, where this parameter gave us the ideal relations for everything. Furthermore, if we consider the main graph, which are the related to our weighting methods on how we took it, it considers where the connections are basically how the things are interconnected. But we also had to calculate something that how these things affect each other. That is basically the edge thickness, which is being controlled by the specific weights and the specific tau variables and k variable value parameters that we selected. Now in this code, every edges that we store had two attributes. Now the city count is how many of the cities agreed, and the weight methods are basically how we are weighing them. First of all, the weight method one that we took was the average cosine similarity across all 15 cities, and the weight method two that we took was basically the count of the sittings themselves. Now furthermore, in M1 we use the weight method too. A thicker edge usually means that more cities agreed, whereas in M2 a thicker edge means the average similarity was higher, meaning that more cities agreed to each other, mainly because they look similar but the differences didn't matter. An item pair might have 10 cities agree at just barely tau is equals to 0.7, high city count but a moderate average. Another pair might have only 9 cities agree but the similarity in each is 0.95. Thus in both the edge thickness varies greatly and shows a very different value. Furthermore, now if we look at the bottom right, which is closely related to the ones on the left but are completely different, which because that is the year for 2023, yet the rights are for the years 2024. Now we can already see there is a visualization difference. There are almost no connections and no thickness in the lines themselves. There is a reason for that, because in 2024 Pakistan was in a year of a regional price divergence, because initially when people had economic stability in the earlier 2023, these edges accurately represented them. But moving on to late 2023, where any economic instability occurred, and then further on moving on to 2024, there was a lot of changes where very few cities agreed with each other and the interconnections were very slow and weak. That is why the 2024 graph is very sparse. Okay, next slide, Ahmed. Now, this slide is mainly about how the concepts that basically led these graphs and how it all ties back to our discrete project. Now, first of all, as you can see, the food dominates the degree centrality, which is again all of the connections that the things have themselves. Why is that? And it dominates this every single year. This is because food and non-alcoholic beverages, things like tomatoes, pulses, wheat flour, appear in the top 5 a lot. This makes sense because food prices in Pakistan are highly sensitive to any other changes. Fuel costs affect the transportation of all food. Weather affects crops everywhere. Import costs affect cooking oil nationwide, as well as the cooking appliances that are imported. So when one food item's price moves, others tend to follow in the same direction. This is mainly why they are connected so strongly with each other and with all of the other categories. Furthermore, if we consider the transport and housing, they do not act as hubs where everything is contained. They are interconnected and linking each other. This is where the concept of betweenness centrality comes in. Betweenness centrality basically measures a thing that is in the middle of a degree centrality, where degree centrality may show you the connections. Between centrality shows you what is actually connecting them. These are the nodes that come between two nodes and also show the shortest path between those two nodes. High betweenness usually means remove this node and many pair of items will wither. Now, a primary example of this related to our discrete project was that items like petrol, high-speed diesel, gas charges, etc. have an extremely high betweenness, even though they don't have the most connections, meaning their degree centrality is low, whereas their betweenness centrality is very high. As a result, they are the connective tissue of the network and are interconnected with everything. Economically, this also makes sense. Fuel affects almost everything. It affects the cost of transporting food and the cost of manufacturing clothing. This is why these are located between the two interconnected hubs. And furthermore, if we consider the cross-category transmission, after building the graph, we mainly checked each edge and how they were related to each other. We consistently saw the 60 to 70% of edges are within category or the same category, where the same category items move together, meaning that, as I said before, any food that whose prices move, then others tend to follow. Whereas the other category items also differentiate due to cross-category transmission. These cross-category edges are the interesting ones. Food connecting transport, transport connecting housing. These confirm what economics call cost push inflation, where a rise in one thing may include a rise in another. And lastly but not least, smaller categories have fewer edges but higher agreement when they do connect. Think about health items or alcoholic items. These are only one or two items in the sub items in the list, and also they are very few in number. So compared to food or the other major categories, you may not find them very prominent in the graphs themselves. However, almost every time we saw that when a health item does form an edge with another item, the city agreement count is extremely high, meaning many cities agree to have these items. Why? Because again, looking at it from a realistic and economic point of view, medicine and tobacco are often government regulated or imported at fixed rates. This means that when the price is moved at one place, it is moved to another place. Thank you. I'll move on to Ahmed.
So I'll be covering temporal and sensitivity analysis. For temporal analysis, when we compare the three yearly graphs, most edges are year specified. They appear in one year and disappear in the next. Only a small number persist across all 3 years, meaning most movement is driven by short-term economic events. However, a few food staple items consistently stay at the top five by degree centrality across all years. So the core hub remains stable, and even when the connection shifts. For sensitivity, we tested tau and k. For tau at zero point 0.5, the network is too dense, and for zero point 0.9, it's too sparse. And at zero point 0.7, we get a balanced interpretable network. As Sarim earlier told us using this graph, as you can see here, top right corner. Coming back, for k, value of 5 allows too many weak connections. 11 is too strict and 8 gives right balance. So both parameters are justified by the data, not chosen arbitrarily. 4 findings and policy implications. 1. Food is always the hub. Food items have the highest degree centrality every single year, consistently over the most connected nodes in the network. 2. Cross category edges. Confirmed price transmission. Food and transport connections show the microeconomic forces like fuel prices and exchange rates push unrelated goods up and down simultaneously. 3. Most co-movement is translucent. Most edges exist for only 1 year, only a few persist across all three, representing truly structured price relationships. 4. Parameters confirmed optimal sensitivity analysis validates that tau at zero point 0.7 and k at 8 produces the most balanced networks across all configurations tested. Policy implications. So the items with the greatest centrality are the most critical inflation monitor targets. Price talks to these goods spread the fastest through the entire CPI basket. So that's it from my side. Thank you.